Let's see, in my world, I wanted to just share with you guys a couple things. So one of Jeff's suggestions in the previous conversation was around having a second sensor installed, although it's probably getting a little grainy there, but you can probably still make it out. So that's one of those multi-turn potentiometers with a hodgepodge of 3D printed parts there, marrying that up to the Half Moon gear and giving me an analog signal off of that, feeding up into the teensy that's lying under there. That's also getting the signal off of the magnetic sensor. And what that's letting me do, and this is out on, I like this GIST thing. How do you pronounce that, Matt? Is it GIST?
Yeah, I don't know. I think so.
GIST is J. So anyway, it's really an easy way to, I don't have to publish. When you guys say, well, where's the code? And I can just say, well, it's right here. So the last time, you talked about how do I know that the wheels are straight? And so now I can read that analog sensor and I know that it's basically 540 is what that needs to be. And so I've given it a bit of a buffer there.
Can you make that a little bigger?
Can.
Yep.
And so once that analog sensor is giving me a reading that is within that range, then I can go on with the rest of the process. So I mean, it's very crude, and I'm sure better programmers would have a much more elegant way of doing that. But so that's one of the things that, I only do the stuff that Jeff and Matt tell me to do. So Jeff told me to do this, so that's why I did that. It's a joke. I didn't get a laugh out of either one of you. So anyway. So that's one thing that I did. The other thing that I spent time on is the why did I get that? I shouldn't have got that message. Come on, I'm supposed to be on.
It uses up the battery quite quickly. So you might want to...
Why did I get that error message? Let me try this. Damn corporate networks. I may lose you and I'll have to dial back, but we'll see if this, how elegant this is. See if I can switch over to LTE and offer my company Wi-Fi without losing you. Hey, I haven't lost you. That's good. Hey, that worked. Cool. So the other thing, this is code that's detecting this speed sensor, and the other thing I had to do is go through and update this code
We can't,
to,
I can't see your screen and you
Looks
seem
like
to be
it's
frozen,
frozen.
so you might have to.
stop sharing. How about now?
It just says you've started sharing screen, but I don't see anything yet.
No? Do I still have you?
Even your video's frozen. Well, from my side, it updates every once in a while.
Crap. Did that repair it?
Your video is moving.
Let me restart sharing again. Any joy?
It's just showing a blank screen, so maybe you picked the wrong screen or picked the wrong window or something when you tried sharing.
Trying again, hold on.
I can see it.
Yep, fixed it.
Sorry for that technology interlude. So the other thing that's out here on GIST is the code for the left speed sensor, and the update for this is basically using Jeff's magic code to get this bit shift process implemented. So now instead of what was 160 or 170 line piece of code, now it's 130 line piece of code. So I'm 40 lines code more efficient at tracking and using that process. So that's also out there. And then the next thing to just share with you is I'm trying to get Vinny a clean bag file and a test file so that I can then run hopefully his navigation. I don't know quite what to call it. I mean, I watched the video from Tuesday night. Sorry I couldn't be there, where he went through, you know, sort of how MoveBase works. But I'm trying to, you know, be able to say, hey, here, I ran this square in my backyard, and here's the bag file from that. And this is basically a Python program that I want to be able to read in. And Jeff's got this program that runs based on, you know, distance traveled, and I wanted to do that with command velocity. And so this is code that I've written but not yet tested that basically will take an input that I load in and run a mission, spit out these command velocity statements, track how many meters I've traveled, and then stop and go get the next message, and then run the next statement. So code written, not tested. That'll be the next thing to do. So that's where I'm at. And this is an interesting statement that I've found. That's not a full level subscribe to the message. It's just go grab one reading, if you will. I found that people were using that statement to get like a camera, an image from a camera. And so I borrowed that for running in this loop process. Do I still have you guys?
Yep. That's pretty cool. Very good job.
So I don't know. I watched maybe 40 minutes of Vinny's presentation as on the whole. Are we implementing ROS 2 now? It sounded like he was talking through implementing ROS 2.
So our current navigation stack is based on ROS 1, but we are, Vinny's also looking at the navigation stack for ROS 2, but that's not quite ready yet.
Well, I'm hoping to be able to send command velocity statements both based on time and meters traveled. And if I can send it on meters traveled, then I can also, without much to do, be able to say, go until you've reached a certain GPS point as well, although it won't, the steering won't be obviously controlled. But anyway, so getting a little bit more sophisticated in the controls. Wouldn't quite call that navigation. I would just say a little bit more sophisticated in the controls. What's going on in your world, Jeff?
Well, at the last meeting, I was saying that on my lawn tractor, it's got, instead of having foot pedals to make the transmission work, it's got just a lever sticking up. And I was trying to explain, it had this slot cut into it. Well, here's the plate that was on the thing, and you can see if this is the arm sticking out, it goes along, so if you're going forward and you pull it back, it drops into the neutral and stops there, so you don't accidentally go reverse. If you want to go reverse, you have to pull it over here and then pull it back, and you can go like this. And then when you want to stop, it drops back into the slot again. So anyway, that was going to interfere if I just try to move that rod back and forth with a linear actuator or a RC servo. So I just simply took this off. And then when I took it off, I could see more of the mechanism. So one of the things I noticed was if I were just to unbolt the connecting rod that goes to the transmission control arm, so it looks like it's just a little short arm like on the Cub Cadets that you can hook onto. And there doesn't seem to be any room in there to do anything, but I realized I can stick a rod through the back. There's a hole in the back for some reason. It looks like one of those things where you put a chain through, maybe to lift it up or something, but there's already a hole cut in the back. If I take a long rod, I can probably connect to the transmission arm and run it clear out the back and put my RC servo on the back of the thing. So I was toying with that idea. And then I got around to pulling the steering wheel off and trying to decide what would be the quickest way to get a power steering motor stuck on there just to test it out. So that's kind of where I'm at right now with that. I got some parts on order, but they should show up sometime, I don't know, today or Monday or so. Oh, I did order that belt to replace the drive belt, but I didn't get around to put that on, so I haven't done anything with that yet.
Besides the belt, what other interesting parts have you ordered?
Let's see. Well, number one, I've got these ball joints that are 6 millimeter, and I didn't have any 6mm threaded rods. That's one of the things that's showing up. I just ordered like a 10-inch piece of threaded rod for that. And then Monday, I ordered some different ball joint type gadgets that are supposed to show up. So mechanically, that's just the pieces that I'm kind of, I keep saying I'm waiting on them. That's just an excuse to not do anything, I think is what that really is. So
We should have a garage sale because I think I probably have some of that stuff that I'll probably never use.
I think that's all I had to point out right now.
Matt, anything to share?
More fun playing with the Delta arm. I don't have the driver written for ROS yet, but the goal is to make a little action server. You send basically just XYZ and then comes back with success or failure.
How's the Delta arm going?
Good, it's nice. I don't know how well it'll work, but this is just kind of just to learn how it works.
And I've lost video on my end. I'm sure it's a problem on my little issue earlier. I see Holly Tomlinson, and I know it's not Holly, but
Well, that's me. I'm having trouble with my computer, so I'm on my wife's phone.
how is your how is your you have the what do you call it, the pivot, the center pivot machine?
Oh, yeah, no, it's well, I've had quite a week. Yeah, no, I haven't made much progress, but we have some.
Nice.
Nice.
Go ahead, Jeff. Tell him.
Go ahead, Jeff. Tell him.
You're going to need your bigger box.
You're gonna need your bigger box.
We can't hear you, or I can't.
Yeah,
No, I can't hear him.
we're not getting the audio.
How about now?
Yes.
Hear me?
Yes.
Okay, yeah, it was just my headset wasn't working. My power supply blew up, and then I managed to corrupt my operating system, and I've tried to replace it all, and now it's not going on Zoom. So, yeah, I had a bunch of stuff for screen sharing, but anyway, yeah. So this is my controller, and there's a receiver that goes with this transmitter, which is these are just 24-volt switches, and all of my solenoids and contactors and things like this big contactor, they're all 24 volts, so that makes it really simple. But to be able to get this in the middle of it, this is just a Arduino with a screw terminal shield, and I've got this optocoupler module, so that all my 24-volt lines should be able to feed in the top here, and be able to get signals into this 5-volt signals into this thing, and then signals should be able to come out through this relay module. Yeah, so that's the plan, and this is a 24-volt to 5-volt buck converter, and then I've got a Raspberry Pi over here that I guess eventually will connect in to this bit. My main problem at the moment is trying to get the DC motor speed controllers to be controllable by the Arduino. I did buy this thing, but it started smoking as soon as I used it, and this is a speed controller. So yeah, that's no good. But so that's for my. That was going to be for my smaller of my. I've got 2 electric motors on my machine. So the big one is running on. Let's see if I can show you this. This is how I'm doing my screen share at the moment. Can you see that? This is a 48 volt DC motor speed controller, and at the moment I've got a potentiometer just hanging off the side of my machine, which I can adjust the speed of the motor by turning it. So I bought these little. Let's see if I can get that. Yeah, digital potentiometer chips. But I've since discovered that the signal voltage coming out of that speed controller is like 13.4 volts, and I think if I put 13.4 volts through this thing, it's going to blow it up. It doesn't take 13.4 volts, and because the speed controller I bought for my small motor blew up, I think I might have to buy one of these big Curtis speed controllers. And I just found out that this listing gives me an option of, I think last time I bought it, it didn't really give me the option, but it says I can choose either to have the accelerator be a 5K potentiometer, or to have a 0 to 5 volt signal. So obviously it'd be much easier if I'd chosen to have a 0 to 5 volt signal directly into it to control the speed. Yeah, so that's what I'm worrying about. And I found you can buy there's this thing which is can everyone see that?
Yep.
That's the programmer, which there's a port that thing plugs into, and then a USB thing. So that would let me reprogram my controller, which presumably will let me use 5 volt, 0 to 5 volt logic. And I think if I did that, I could just use a PWM pin off the Arduino without needing digital potentiometers and all of that kind of stuff. But yeah, the programmer is £280, and the controller itself is 117. So I might end up just buying a new, or actually 2 new motor controllers. Yeah, so that's where I'm at with that.
How many amps are you using on that motor controller? Is there a reason why you have to use that type?
Well, this one will do 48 volts at 325 amps.
Holy
So
cow.
yeah, it's pretty. Whereas this thing said it was a 48 volt 60 amp controller, and I was just trying to set it up so that I could use my multimeter on this on the potentiometer attached to this and see what it needed. but yeah, it just as soon as I put a little bit of throttle on, the motor started going full speed, hell for leather, and within about 2 seconds, or maybe less, a load of smoke came out of this. So yeah, I don't rate. I mean, this cost £11, whereas yeah, I'm not using 325 amps. I guess it's probably yeah, it's probably not much over 100 amps much of the time. Yeah, so
you need 100 amps to produce a consistent PSI for your hydraulics. That's what, I mean, that's the reason for that many amps, right?
Well, at the moment, it's not building up pressure in that kind of way. So you know, it would only develop pressure if the vehicle had like substantial resistance and the motors was working hard. So
I guess I'm just,
I've
I mean, I'm not a double E, but getting a motor, trying to digitally control that many amps, that's a challenge versus,
well,
you know, other relay-based approaches or other approaches you could imagine.
so this, I can show you, these are the pins on the back of this controller. So there's 48 volt positive and negative coming from, oh no, these two are the battery connections and these two are the motor connections. And then you've got these little spade connectors which connect to some electronics inside the controller. Yeah, and I'll show you down here, it does say that it is, yeah, here, accelerator mode 0 to 5 volts. And it gives you the option. These things are on like mobility scooters and things like that quite a lot. So you can just choose the throttle type. So I think if I'd have, basically I got that one instead of getting that one, which is what the source of all my trouble. But I think it should be, you know, with the right throttle types, it should just have the internal electronics to be able to take a PWM signal line from the Arduino and output. I guess it's just it's a big PWM controller. That's my guess.
Just a
Yeah,
word of
but,
warning
I mean,
on that. The PWM signal coming out of your Arduino is not a voltage. It is an actual PWM. It's a square wave coming out. So if you want to convert that to a voltage, you need like a resistor and a capacitor to put in there, and that smooths it out and it'll convert that to a voltage. And I was just looking, and I ran across one YouTube article here talking about it. But anyway, you can't just connect those two together. It probably will not work. You need to put something in between there to convert the PWM into a voltage for the motor controller to understand that.
yeah, good tip.
I was doing some searching
I'll,
here. I haven't found a good website that tells you, but there it's a fairly common technique to do that. And I'll do some more digging here, and I'll see if I can post some links to it.
Yeah.
And I think the Android or whatever that thing is, Arduino has an analog out, has 5 analog pins. Or are those only inputs?
It has analog inputs.
Okay, but no analog output.
but you can use an analog write command, which generates a PWM, but it is just a PWM, it's not a voltage. So you have to convert that PWM into a voltage,
Okay.
which isn't hard to do. It's just that you got to have, as I say, the
Right.
simplest way, use a resistor and a capacitor, and that'll smooth it out and give you a DC voltage. It takes the average of the PWM, gives you a voltage out.
That makes sense.
And some of the fancier microcontrollers have an actual analog output pin, 1 or 2 output pins on some of the ARM processors will have that. But if you just have the standard Arduinos, it's not that hard to convert it. It's just that if you hook it up, it's going to confuse it if it sees a square wave coming in on what's expected a voltage.
Yeah, that makes sense. So with my Arduino, I was going to do things like the Arduino code I've been writing has it so that when I press, instead of at the moment, you press forward and it goes forward at full speed, or whatever it is you've set on the potentiometer, and then you let go and it stops. And the program I've been trying to write is something where with each consecutive press of the button, it goes a little bit faster. So it, incrementally increases the speed, and then you press the button and it incrementally decreases the speed until you stop it, and then you keep pressing the button and it incrementally increases the reverse speed. And yeah, to make it just a bit more usable as a remote control machine. So I guess then I'm just thinking about how I would incorporate the Raspberry Pi with ROS later on, if if the same signal inputs going into the Arduino could come from a ROS navigation program, or if I need some different kind of interface between the two, or if I guess I just don't want to create future problems by how I solve my current problems. Does that make sense as a?
Yep. I don't know. I'll take a shot at that, John. But there's many ways to do things, obviously. So, like if you're pushing that button, that is like a relay contact that's being turned on, and when you let go of the button, then that relay comes off. And so you're just with the Arduino, you can catch each one of those edges as you're putting that. It will send like a 5 volts and then 0 when your thumb is off.
Yeah.
So that will work. ROS, like you're saying, the combination of having just like a PC, like a little Raspberry Pi, and the Arduino or a Teensy or some little microcontroller, that's a pretty powerful combination. So what will come from the Raspberry Pi to your Arduino may be a little bit different message, in the sense that the Raspberry Pi will tell your robot how fast to drive. It's called a command velocity, and basically it has how fast you want it to go, and then where do you want your wheel angle to be.
Yeah.
So you may have a couple different pathways. For example, you may have an autonomous pathway, and then you may have a joystick pathway. And you do that in the software stack. So like when you use the joystick, it will listen to the joystick commands. And so you can program that with your buttons and do all of that type of thing. And then when it's using the autonomous system, it drives that pathway.
Right. Okay. Yeah.
But if you're wondering, I was a little bit fuzzy on the question. If you're wondering whether you're only going to need a Raspberry Pi, if that was the question, I would say no. Think of the Raspberry Pi as a high-level controller. You're going to need a low-level controller that's operating at a Raspberry Pis are not very good on analog to digital signals. They can do it, but they're not really designed for that, where a micro controller like an Arduino or something in that family is. So at your very low level control, part of your, what's typically referred to as your stack, my simple
Right.
view of the world is you're going to need something like an Arduino or a Teensy or a Blue Pill to interact with your very low level sensors.
Right, yeah. It sounds like I've got the right kind of idea with I had a question, Al. Your nice plastic sprockets that you're using to drive your rotary encoders from your steering column. Is that what that picture is?
Yeah.
Where do you get those sprockets? Are they 3D printed or do you buy them?
I 3D printed those, yeah.
Right, yeah.
Self-taught, clumsy Fusion 360 3D printer guy. Fusion 360 is the authoring program, and then 3D print those. It's pretty straightforward. I mean, if you ever want help doing your first one, I'm happy to help.
Cool, yeah. Oh, I probably will. Thanks for the offer. I probably will take you up on the offer of a one-on-one call at some time, but I'm going to try and get myself a bit further ahead so that I can make the most of it before I do.
Yeah, I think I have some instructions written down somewhere on doing some of that. If you get, I mean, you can, that's a whole nother rabbit hole to go down.
Well, I think I found, so the rotary encoder I'm looking at is, it's got a 6mm shaft. Yeah, this kind of a thing.
I can't see your video just so you know, because I screwed up my computer on my end, but I can hear you.
Okay. Yeah, I'm just pointing it at my screen where I've got a rotary encoder. Yeah, it's got a 6mm shaft, and I found a load of like remote control car sprockets. One with a 6mm hole in the middle. So yeah, I think I can get that. I think I can make that work. Anyway,
I'm using that encoder on one of my motors that I'm running. I just have a little flexible coupling that goes between the end of the motor shaft and the encoder shaft.
Right. Okay. Yeah. Good. So I guess that encoder will work. I'm planning on. I've got a 2-inch solid bar, which is my central pivot. So I'm going to put try and put a rotary encoder on top of that to get steering angle, essentially.
Also keep in mind those encoders, they're not absolute encoders. So when you first start the thing up, you have to tell it where the 0 position is. So if you're just sitting on a flat ground and you're pointed straight, then you can say, okay, 0 out the encoder. And then it tells you to move one direction or the other. If that makes sense.
Yeah.
I mean, I'm just going to share this as an example. I don't know that this has been updated in a while. It looks like it's been a year. but the rabbit hole that I was referring to is there's a ton of different authoring. I say a ton. There's at least 4 or 5 authoring tools. I happen to borrow my 16-year-old daughter's email account and I got access to the educational version of Fusion 360. Inside of Fusion 360, they have a Spur Gear, what do they call it?
Yeah, nice.
Add-on. And they make it reasonably easy to trigger or generate a gear. I wrote some instructions on what I did, and it spits out a gear, and you've got to find a 3D printer to print it. You've got to add some dimensions to generate what I call a D portion. But it's, once you've done it once or twice, it gets to be pretty easy. But it's, Matt and I sort of have a joke. It's one more thing to have to learn. Did I share my screen? I don't know if I shared my screen.
Yeah, we saw a screen with a gear
Yeah, I saw it.
doing on it.
Oh, okay.
I tend to use FreeCAD. I don't. It'd be. I'll
There
have a
you
look.
go.
See it. I mean, that tool looks really handy.
Fusion 360's got a ton of people who've done YouTube videos, which has been, like a lot of things. It's watch a video, learn a little bit, struggle a little bit, watch another video, learn a little bit more, struggle a little bit more. That's been my 3D modeling learning journey. And, you wouldn't want to fly an airplane that I designed. I'm making do.
I posted a link in the chat. Is that the rotary encoder you're looking at? And is that AB? Is that quadrature?
So I'm struggling a bit because I'm on a phone.
Okay.
Do you know how I get the chat up?
Oh yeah. Oh yeah. Here. I think that brings it up. I know that's the participants.
Sorry, well, I'll get my computer fixed and working by next week.
There you go.
Right, yeah.
You can use my laptop.
Well, I think the one I'm looking at is 400.
400 ticks per revolution.
400 BM. I've never looked at rotary encoders. I don't know what the. I suppose 600 PR DC. Is the one that you sent this link to? Do you think this is the kind of thing that I should be getting?
Well, it's just a question. I wasn't sure. I've never used that one, so I don't know. 600 ticks per revolution, 5 volts. And then the AB 2 phases, I didn't know if that means quadrature. And then for $13, $14, pretty good deal.
Yeah,
That-
yeah. Oh, I found it.
Those are
Yeah, oh.
quadrature. And that is the one, I'm using the one that's 600 pulses per revolution that I'm using on my current design.
Okay, I'll get the same one just so that if I have trouble with it, then at least
Well, it
using the same.
just depends how many counts you want coming out of this thing. Because the other thing is, depending how you decode this thing, you can either decode it as a 1x, a 2x, or a 4x. So you either get 600 counts, or you get 1200 counts, or you get 2400 counts if you go with the 600 count per revolution encoder. So if you're going to plug it into an Arduino, and you may or may not get it to work with a standard Arduino. I keep telling people that when I do it, I get a microcontroller that can directly understand that. It's got hardware built in that'll take like 2 megahertz count rate coming in, and the Arduino is not going to do that fast. So on one hand, a lower resolution encoder might be better if you're trying to use an Arduino, but if you can make it work, then it should work no matter what. Now, the other thing to keep in mind, this is an incremental encoder. So as I said, you're going to have to zero it out when you first start, or have some way to know where it is, or you can go some kind of absolute encoder. So if you go just a potentiometer with an arm on it, so it moves the potentiometer back and forth, you can read that as a voltage, and that'll give you an absolute position. So when you first turn it on, you know where you are without having to do any calibration. And then the sensors that Al is using, those magnetic sensors, they basically are absolute sensors too. That'll do 0 to 360 degrees. So when you first turn it on, it knows where it's at. And then you can also get that sensor like Al has packaged in a thing that looks like a potentiometer. So you can just mount it like a potentiometer, put an arm on it, or if you've got an actual, shaft that's rotating, you could actually, just connect it right to the end of that shaft. So you have several options there to make that work.
Yeah. Yeah, my priority is just to have the central steering angle. Like I think I'll have encoders on each wheel ultimately, but just having one that measures the steering angle as it moves seems.
And for that, I think you'd be happier with some kind of an absolute encoder, either a potentiometer or one of these magnetic rotary encoders. And that way, when you first turn it on, whatever angle it's at, that tells you. So if you have a potentiometer, it just tells you what the, what angle your potentiometer is at when you first turn it on, and then you don't have to do any extra monkeying around. So a lot, and then also it depends on how much resolution you want to get out of the thing. So once you get, say, put a potentiometer with an arm, it may travel, say, 90 degrees of the total range, and that may, that's going to cut down your resolution if you're not turning the full range of the potentiometer. But just to start with, just bolt something on there and try it, and that way you can get a feedback, and you can decide, is that enough resolution to tell you what you want or not. You put some duct tape on there or hot glue or whatever, just to put it on there, just to verify it's going to work. Or just hook a potentiometer up to your Arduino and say, this is how far I expect it to turn, and turn it back and forth and see what the numbers coming out of it are, and see if that's going to be enough resolution for what you want.
Yeah, I'm not going to waste a huge amount of money by buying the wrong component. I think it's a good thing about moving on from the hydraulics to the electronics.
I have a potentiometer question, if I may. So I'm using this 533 model, and I'm taking VIN off of the Teensy, which is 5 volts because it's USB, and feeding it into the down here, pin 3, I think, pin 3, if I'm remembering right. And this is a 3-turn pot, but I'm only getting 2 turns out of it. And by that I mean, when it gets to, say, 1023 as the output, I've still got to turn left. Any idea why that is?
That's because you're powering it with 5 volts instead of 3.3 volts. Because your A to D input wants to see 3.3 volts, so you're exceeding the range of that. So look on your teensy, it's going to have a pin that says 3 volts or V out or something. So it's going to be that they're going to take the 5 volts in and convert that to 3.3, and then power your potentiometer from that. And then when the A to D reads that, it'll give you your full range.
Well, there you go. Easy answer. How did, how is it that I would have known that I should only give this thing 3 volts? That's more about because of the teensy then, right?
Yes, it's based on the teensy A to D input is 0 to 3.3 volts. And if you look at the spec sheet somewhere, it'll tell you that.
Got it. Thank you. I'm sorry, John, I was using some of your time.
No, it's fine.
And the other thing to consider, as Al says, he's using a 3-turn pot, and for the steering on your center pivot or your articulated steering, it's going to be a fraction of a turn. So probably you just want a single turn pot on that, which will be cheaper too. You just get a little, whatever you got laying around will probably work. The only thing, keep in mind on potentiometers, some of them are what they call linear taper, which means as you turn it, it gives you a 1-to-1. And some are called audio taper, which has a logarithmic curve that comes out of them. So if you're yanking it out of something, if you take a volume control out of an old radio, that's going to be the wrong kind of response coming out of the thing.
Right. I have a potentiometer. I'm not sure if it's linear or not. I'll check.
Yeah, you could. If you set it to 0, it should be 0. You set it to max, it'll be whatever the max is. You put it in the middle, it should give you, half of whatever the max is. And if it's a logarithmic one, it's going to give you some really stupid numbers coming out of it. So that's just a quick check to do on that. Or if you're reading it with your A to D converter, you can, as you run it from one end to the other, you can see if the numbers are basically, at a quarter of a turn and a half a turn and 3/4. Are they, are they linear to wherever the position is? Because the logarithmic one it's going to start off, I think it's turning really slow. As you get closer to the end, if you plot it out as a curve, it's going to be a really, really funky looking curve. And they do that because the human hearing is based on logarithmic values. Something is twice as loud. Whatever your hearing is logarithmic, so they just made a potentiometer that matches that, and that's why they came out with those type. So anywhere in audio circuit, you might run into that kind of stuff.
Right. Yeah. Yeah. Well, I've got the ones which I bought for my speed controllers, but aren't going to use anymore. I think it's a linear one. Yeah, I'll check it with my multimeter.
And then one other thing, I said I was going to look up how to convert the PWM to a voltage. I posted a couple of links there in the chat, and I'm not sure they're the best links. Here, let me pop this up here. So on the second link that I posted, they figure 1 they show, and this is what they're saying steady state. So if you're putting in the really narrow pulses, they're short pulses, see your voltage is down, and then they put out about a 50%, the voltage comes up to match that. And then up above, they were saying in figure, well, it's also figure 1, PWM. Oh, they're both figure 1. So this other one here, they're saying if you want to get an actual sine wave out, you can actually modulate the thing, and the resulting thing will be like a sine wave coming out of it. But what you want is the steady state stuff here, which is showing you the, if you just put this constant value in, that's the voltage you'll get out, and at 50% PWM, you get this voltage out. So that's basically what you're looking for when you're done. It'll just convert the pulses coming out, convert that into a voltage for you.
Yeah.
And in this case, since if it's a 5-volt Arduino, then your 0 to 100% will end up running through the circuit. It'll give you a 0 to 5-volt signal coming out of it. If you needed something, one of the industrial standards is 0 to 10 volts, so you'd have to do put some extra electronics on to get it to go 0 to 10 volts instead of 0 to 5. And then back to Al's point, he's using a Teensy, which is a 3.3 volt processor. If you convert the PWM to a voltage, it's going to go 0 to 3.3 volts. So just, again, just something to keep in mind that that's what that's the funny little things you run into as you try to interface this stuff.
Yeah. Is there with the one the wrong controller that I've got? I measured it. It's putting out 13.5 volts going to the potentiometer, and throughout the speed range of the motor, I measured the voltage drop from the input pin to the wiper pin, and it was about the voltage drop from those two pins was about 0.8 volts when the motor was just started engaging. It went up to 3.5 volts when the motor was at full speed. Am I right in thinking it's really difficult to get an Arduino to be able to control that?
Well, you were talking about using that digitally controlled potentiometer, and you might check that. I don't know if it's got, if the output has to go 0 to 5 volts, or if it just looks like a resistance, which means you could probably, run maybe up to 20 volts on it. Yeah, if you look at the spec sheet, it should tell you what that is. If it just looks like a resistance, just looks like a resistor, then it shouldn't matter really what the voltage is coming out. But depending how they built it, it could be that it is limited to, say, 0 to 5 volts on what you put on it. But it seems like if it can handle the voltage, then you should be able to use what you have there. The other thing is that it could be that you're reading the voltage on the potentiometer. It could be that it's not really a voltage. Like again, it might go back to this. It's generating a PWM internally somehow. So it could be that that's not necessarily, the voltage you're seeing on there is not, it could be it's not voltage controlled. If it is voltage controlled, you could probably pull the potentiometer off and put a voltage into it and just directly drive it that way. But since they sell two different models, it seems like maybe that's not going to directly apply to that. So in order to really know, you would have to put like an oscilloscope on it and on that potentiometer, see if it is just a voltage that is coming off that thing, or if it's some kind of pulses that are happening.
Right, I see. Maybe I'll experiment a bit, see if it blows up or not.
And it could be if you punch in the name of that controller and go to Google and do some searching, it could be other people have tried to do this, or maybe look up application note in that controller, and they might say, here's how you convert, say, from a microcontroller to drive that thing. So there may be other people out there that have tried this and have this figured out.
Those Teensy guys, they say they're 5 volt tolerant, but that's like, that just means you're not going to release the special smoke if you put 5 volts on.
I was always curious about that because I knew the analog only goes up to 3.3 on the input, but I didn't know what happens if you put 5 volts. I guess you've proven that it doesn't blow it up if you do that. So that's a good thing.
I didn't release the special smoke. Okay. Well, guys, we're over the hour. Anybody for any more? Matt, you good?
Good.
Jeff, good?
That's all I've got, I think.
John?
Oh, will the chat get put on the Slack? That's what happens normally, isn't it?
Yeah.
Right.
People don't forget.
That's all automatic, isn't it, Matt?
Or if you
It's
go
artificial intelligence.
if you're on your computer, there's a little button down there you can click and you can say save chat, so you can save it at this point. But if you're on a phone or something, I don't know how you do that. But there is a way to save those.
Great, thanks everyone.
Have a great weekend, everyone.
Okay,
Yeah.
see ya.
See you next week.